Hello everyone, and welcome to today's video on volumes of revolution. This video is focused on the AS questions, where the integrals are fairly easy to deal with, although you do revisit the topic in year 2 to use more advanced integration techniques and parametric equations and stuff. But with that said, I have picked 3 particularly challenging questions for today's video, largely focused on dealing with multiple volumes, which is probably the hardest part of the year 12 topic. And just before I get into the top tips, could I kindly ask you for any feedback that you have so far on this video series, like video length, video quality, in the comments. For example, let me know whether you prefer this longer, comprehensive video length or whether you prefer shorter videos that each go through a single question. Anyway, moving on to the top tips. So, first of all, we have checking limits carefully. Have they given you in the question X or Y limits? Like, for example, if it's between where X is 0 and 2, but you're rotating about the Y-axis, then you want to change those into Y limits by substituting into the function. Secondly, remember to integrate X squared or Y squared. Don't forget to square it before you integrate. And remember to multiply by pi. I mean, these are pretty obvious things, but it's easy to make mistakes on volumes of revolution, and that's the main thing for this, is just being careful. And the other thing is about thinking carefully when adding and subtracting volumes. So I like to label my diagrams using, like, for example, V1 and V2 to make regions clear, and then decide before I get far into it an approach or a strategy to solving the question, which ones I'm going to add and subtract and so forth. Anyway, moving on to the first question. So we've been told the shaded region is bounded by curves with equations y equals 2x squared and 3y squared plus x squared minus 11y equals 0. So going to be some rearranging there. The shaded region is rotated 360 degrees about the y-axis. Find the exact volume of the solid of revolution generated for 9 marks. And the reason why it's worth so many marks is because we have quite a bit to do here, adding and subtracting volumes. So the first thing to do, and I'm just going to zoom in a little bit, is to decide on our approach. So if we can work out the coordinate of the point of intersection of these lines, and then we draw a dotted line up to that point of intersection, then what we can do is we can start by working out this whole... We can start by working out this whole area, and then subtracting that from this entire area, but not the section which is above the red dotted line. So I'm going to call the whole V1, and the smaller segment is V2. And we're going to be doing V1 minus V2 in order to find the volume of revolution of the shaded region. So to start with, we're going to find the point of intersection of the two curves, which of course we'll do by solving them simultaneously. So we have 3y squared plus x squared minus 11y equals 0, and y equals 2x squared. And it's the y value which we're interested in, because we're rotating about the y-axis. So we want to make y the subject here by substituting x squared for y over 2. So 3y squared plus y over 2 minus 11y equals 0, and doubling 6y squared plus y minus 22y equals 0, and solving that, we will get, we can divide by 3. We get y equals 0 and y equals 7 over 2. those are the 2 points where the curve intersects, and therefore those are going to be our limits in this question. So looking at the whole curve first, so looking at V1, we're looking for the volume of revolution under 3y squared plus x squared minus 11y between y equals 0 and y equals 7 over 2 when we revolve that about the y-axis. So for any y-axis rotation, the volume is going to be pi times the integral of x squared with respect to y, and with limits b and a. And in this case, x squared is going to be 11y minus 3y squared. And we get that by rearranging this original equation here. And then we need to integrate that between, and don't forget to multiply by pi, we need to integrate that between 7 over 2 and 0. And that will give us our volume of revolution. So if we do that, integrating, we have 11 over 2 y squared minus y cubed. And that's going to give us a final answer of 49 pi over 2. That's for V1. And then we need to look at V2. So V2 will have exactly the same limits between 7 over 2 and 0, but this time we're looking for the area and then the volume produced under the y equals 2x squared curve. So I'm going to do that down here. So same formula because we're rotating about the y-axis. And V2 is going to be pi times the integral between 7 over 2 and 0, and x squared in this case, because y equals 2x squared, x squared is y over 2. So we're integrating y over 2 dy, which means we have pi times y squared over 4 between 7 over 2 and 0, and substituting in, we get that V2 is 49 pi over 16. And then we need to go back to what we were originally saying, which was that we were going to subtract V2 from V1. And if we do that, then we're doing 49 pi over 2 minus 49 pi over 16, which gives us a final answer of 343 pi over 16. And that's our final answer to the question. In our next question, we've got volumes of revolution being used to model a candle. So we've been told that the candle is formed by rotating the region bounded by the y-axis, the line OB, the curve BC, and the curve DC through 360 degrees about the y-axis. The point B has coordinates 3, 0, and C has coordinates 5, 15, and the units are in centimetres. Always be wary of the unit they give you in case they change it later on. And we've been given the equation of BC, but here we have an unknown constant A, which we need to find in the first part of the question. And we can do that by substituting in one of the original coordinates. So substituting in 3, 0 wouldn't be a good idea because setting something equal to 0 and then finding the denominator would give multiple possibilities, and it's just going to be a lot easier if we work with 5, 15. So starting with that, we have y equals 15. So 15 equals the square root of 225 times 5 squared minus 2025 over A. And in this case, this is 60 over a, which implies, of course, that a is equal to 4. And that's the value of a. And then we've been told the the curve CD is represented by the equation y equals 16 minus 0.04x squared between 0 and 5. And we need to determine the volume of wax that would be required to make the candle, so the volume of the candle. So here we have essentially two volumes. First of all, we have, so splitting it down here, we have the volume between whatever value of y this is, I'll call this b, and 0 under the curve BC. And then we have between b and whatever the y value of d is, I'll call that c, under the curve CD. So we have two volumes there, and we need to add them together in order to obtain our final volume of the candle. So starting with the first one, and we've now got the equation. Starting with our formula, we have V equals pi times the integral of x squared with respect to y. So here we have that 4y is the square root of 225x squared minus 2025. Squaring both sides, we have 16y squared equals 225x squared minus 2025. So rearranging that to make x squared the subject, 16y squared plus 2025 divided by 225 equals x squared. So we need to integrate this expression with respect to y, and we have 16 over 225 y squared plus 2025 divided by 225 is just 9. So it is a little bit easier if we write it that way, splitting it up. So substituting back in, we're integrating this expression with respect to y between 15 and 0, because looking back, those were our original limits. And this is the expression we're integrating. So if we integrate that, we have pi times 16y cubed over 675 plus 9y between 15 and 0. And this gives us precisely 215 pi as our answer. So that's the first volume of revolution. That's the volume of revolution under the curve BC. Looking then at DC, so we know what B is. B is 15 here, and I'm talking about this B. To find the value of C, we need to find the coordinate of D. And we know the x-coordinate of D is 0, and we know the equation of D, so we can find the y-coordinate of D pretty easily. So I'm just going to switch colour here for the second part. So y equals 16 minus 0.04x squared. So when x equals 0, y is 16. So for the second volume, we're integrating between limits of 16 and 15. So our volume is pi times the integral between 16 and 15 of x squared dy. And if we rearrange this expression for x squared, then we're going to get 16 minus y times 25 equals x squared. So that's 400 minus 25y equals x squared. So we're integrating that with respect to, oops, my bad. Sorry, this is y, no, that's correct, sorry. So if we do that, I'll come back up here. Then we have that the volume is pi times 400y, so I've integrated it now, minus 25 over 2 y squared between 16 and 15. And that gives us an answer of 25 pi over 2. And if we add those two volumes together, that should give us our volume of revolution. So we're doing 215 pi, add 25 pi over 2, which gives us 455 pi over 2, which is equal to approximately 714 centimeters cubed to 3 significant figures. So both of those answers are acceptable, but it's also good to see the numerical answer, get a bit of a sense check, and also for the next part of the problem, or rather the one after, the next part of the problem is asking us to state a limitation of the model. Whenever they ask you to do this in a volumes of revolution question, there are a lot of possible answers which would be acceptable, but one of the safest ones to go for is that it's not necessarily possible to model that situation using the equations that they've given. So equations used may not be suitable to model the candle. That's all you need to say, and that's all you need to say in order to get the mark. And then for part D, they've said, use this information, when the candle was manufactured, 700 centimeters cubed of wax were required. Use this information and your answer to part B to evaluate the model, explaining your reasoning. So, of course, we said that it was 714 centimeters cubed using the model. The actual volume is 700 centimeters cubed. So 714 centimeters cubed is only, 14 centimeters cubed greater than 700 centimeters cubed. So the model is fairly accurate. And I don't know, maybe that discrepancy could be due to the hole for the wick or something like that. So for the final question, we've been given a sketch of a 16 centimeter tall vase, which has a flat circular base with diameter 8 centimeters and a circular opening of diameter 8 centimeters at the top. A student measures a circular cross-section halfway up the vase to be 8 centimeters in diameter. Halfway up the vase. They model the shape of the vase by rotating a curve, which is shown in figure 2, through 360 degrees about the x-axis. State the value of A which should be used when setting up the model. So this is the point where A appears here, and we know that halfway up the vase we have a diameter of 8 centimeters, and therefore this length here is going to be the radius, which is 8 divided by 2, so it's going to be 4. And A is 4. And then we're told two possible equations are suggested for this curve in figure 2. So we have model A, y equals A minus 2 sine 45x over 2, and model B, which says that y is A plus, and then we have algebraic expression which you can read for yourself. And for each model we have to find the distance from the base at which the widest part of the vase occurs and the diameter of the vase at this widest point. So for that we want to find the value of x which maximizes y, and that sounds to me like differentiation. So I'll start with model A here, and since this is an AS paper, you're not actually expected, when this question was set, to be able to differentiate the equation for model A and prove it, but rather to look at the graph and make a visual judgment. but chances are, if you're doing further maths, by this point you might know that the derivative of sine x is cos x, and the derivative of cos x is minus sine x. So I'm just going to quickly prove that, if you're interested, to show why their answer is the case. So we have y equals, and then a is 4, minus 2 sine 45x over 2. So if we differentiate that with respect to x, we can use the chain rule. So we're going to have minus 2 times minus 45 over 2 cos 45x over 2, which gives 45 cos 45x over 2. And we're setting this equal to 0 in this case, because we're finding a maximum. So therefore we want values of x where cos of 45x over 2 equals 0. And looking at our graph, we want a value of x which is negative, since we're interested in this point here. And that's going to be the widest part of the vase. And for that, we can say cos of minus 90 is going to be equal to 0. And for that, we have 45x over 2 equals minus 90. So x is minus 4. We have to be very careful here because it asked us, going back to the question, for the distance from the base at which the widest part of the vase occurs. And here it started at minus 8a. So the distance from the base is going to be a distance of 4. Minus 8 minus 4. So distance equals 4 centimeters. You don't have to use the chain rule and trig differentiation to prove that in the question, but that is why it works. And then we need to find the diameter at that point. So y equals 4 minus 2 sine 45x over 2. And substituting in, we get that y equals 6 when x equals 4. So that's y. And therefore the diameter, since that's only the radius, as we said previously, the diameter is going to be 12 centimeters at that point. Next one, slightly harder, possibly looking at model B. So for model B, we have y equals x plus 8, x minus 8 over 100. And when I was doing this question, I decided to simplify using difference of two squares first, as that makes it a little bit nicer to expand. And then, of course, we're going to separate them out, as we'll be differentiating in a minute. So we have x cubed over 100 minus 64x over 100. Which obviously that can be simplified as well. So when we dy by dx it, we have dy by dx is going to be 3x squared over 100 minus 64 over 100. Setting that equal to 0, we have 3x squared over 100 equals 64 over 100. And therefore, hopefully you can see that with a bit of further simplification, which you should show in an exam, but I'll omit it for time's sake here, x is going to be plus or minus square root of 64 over 3. And looking back to the diagram, the widest part of the vase is at a negative value of x, widest part from the base, where I've drawn that blue circle. And so we're interested in x being minus the square root of 64 over 3 in this case. And the distance from the base is going to be the distance from minus 8. So we have minus 8 minus the square root of 64 over 3, which gives an answer of 3.38 centimeters from base. And to find the diameter, we're going to substitute back in to y in order to find the diameter. And y was obviously x cubed minus 64x over 100. If you substitute in minus the square root of 64 over 3, you will get that y is approximately 5.97 centimeters at that point, and therefore the diameter is double that, which is 11.94 centimeters. So that's perhaps one of the harder bits of the question done. And then we have a 1 mark telling us that the widest part of the vase, the actual vase, has diameter 12 centimeters and is just over 3 centimeters from the base. Using this information and making your reasoning clear, suggest which model is more appropriate. Well, looking back at our models, we have a diameter of 12 centimeters for one of them and 11.94 on the other. So both of them are really close to 12 centimeters, but on one of them we have 3.38 centimeters from the base as the widest point, and on the other we have 4 centimeters from the base of the widest point. So based on those two things, it looks like model B is more appropriate, and you would need to say what I just said as well as your reason, but I've just said it, so I won't write it again. Looking at part D, tells us to use integration to find the volume of the vase predicted by model B, and this question has a lot of algebraic manipulation in it, and it's a bit of a nightmare. I actually made a mistake the first time I was doing this, so I had to go back and fix it, which wasn't very fun. So since we're rotating around the x-axis, volume is pi times the integral of y squared dx, and y was x cubed minus 64x over 100. So y squared, oops, sorry, I almost forgot the 4 there. And when I might have omitted it earlier as well, but yeah, this is 4 minus there. My bad. The other numbers are still correct because I've done this before. Y squared is therefore going to be, if we binomial expand it, we'll have 16 plus 2x cubed over 25 minus 128x over 25 plus x to the 6 over 10,000 minus 128x to the 4 over 10,000 plus 4,096x squared over to 10,000. And we need to integrate that expression with respect to x, which shouldn't be too bad, but a useful piece of advice here is to factor out the 10,000. Because it's a constant term, we can just take it out of the integral altogether by dividing by 10,000 there, and we're integrating between 8 and minus 8, and then I've just multiplied all the terms in the inside by 10,000, so we have 160,000 plus, and then we have 400, well, it's going to be 400 times 2x cubed over 25, which we're going to be left with 800x cubed minus 51,200x plus x to the 6 minus 128x to the 4 plus 4096x squared, and dx, of course. And then actually evaluating that, so we're going to have pi over 10,000 times 160,000x plus 200x to the 4 minus 25,600x squared plus x to the 7 over 7 minus 128x to the 5 over 5 plus 4096x cubed over 3, evaluated between 8 and minus 8, and I'll spare you from actually substituting in because it's pretty boring really, but if you do that, you will get that the final answer is approximately 905 centimeters cubed. That is the volume of Model B, the volume of the vase as predicted by Model B. And then, very last bit of the question tells us that the student pours water from a full 1 litre jug into the vase and finds that there is 100 millilitres left in the jug when the vase is full. So, i.e. they've basically just told us in slight code that the volume is estimated to be 900 centimeters cubed for the actual vase. Comment on the suitability of Model B in light of this information. Well, 905 is pretty close to 900, so 905 centimeters cubed is close to 900 centimeters cubed. So Model B is accurate. So there we go. It's pretty harsh for 5 marks really, that last bit. But there's nothing to it other than just some algebraic manipulation. And this is one of the hardest volumes revolution questions I've seen, remember. There are a lot of easier ones out there too that I've seen. Like there's just lots of ones that have come up in exam papers before. Of course, this is only year 1 stuff. In the final A-level exams, they tend to bring harder integration techniques into it. But this is the kind of stuff which you'll see if you're in year 12. That's it for this video. I hope you found it helpful with your revision. As I mentioned at the beginning, please leave a comment below with any thoughts on my videos or what content you'd like to see going forward. I have plans to move on to further mechanics content soon, as I feel like there's less material available on YouTube for those students. Finally, if you enjoyed the video, please leave a like, subscribe and share with your friends so we can reach more further mathematicians. Thanks for watching, and I'll see you in the next one. Bye.